Welcome to Part 3 of an iGETT Remote Sensing Concept Module. iGETT Remote Sensing is a national science-funded project to support remote sensing education. This is the third part to a three-part module that examines the concept and use of spatial filters in remote sensing. The purpose of this part is to provide the answers to the questions located at the end of Part 2 of the iGETT Remote Sensing Concept Module, Spatial Filters in Remote Sensing. All three of the parts to this concept module can be found on the iGETT Remote Sensing website at http://iGETT.delmar.edu. This slide provides an overview of the 5 review questions. 1. How would you define spatial frequency? 2. What are 3 reasons why spatial filters are used in remote sensing? 3. What type of operation is a spatial filter? 4. How do you define the term convolution? And 5. How do high-pass filters and low-pass filters differ in terms of their effects on an image? Question 1. How would you define spatial frequency? Spatial frequency is the number of changes in brightness values per unit distance for any particular part of an image. Satellite images are often discussed in terms of their high or low spatial frequency. Images with very little change in the brightness values per unit distance are considered to be low spatial frequency images. Images with lots of change in brightness values per unit distance are considered to have a high spatial frequency. For more information on the concept of spatial frequency, please see slide 3 through 5 in Part 1 of the Spatial Filters in Remote Sensing Concept Module. Question 2. What are 3 reasons why spatial filters are used in remote sensing? There are 3 primary reasons filters are used. The first and second reasons are to improve the image for further analysis, or to improve the image for some type of automated feature extraction. The third reason an analyst might use spatial filters is to remove or reduce satellite sensor degradation, or noise. For more information, please see slide 6 in Part 1 of the Spatial Filters in Remote Sensing Concept Module. Question 3. What type of operation is a spatial filter? Spatial filters are considered local operations. Local operations use the brightness values of a series of pixels surrounding the base pixel to determine a new value representative of the base pixel in the output image. This type of operation differs from a point operation, where surrounding pixels do not influence the base pixel value in the output image. For more information on the concept of a local operation, please see slide 2 in Part 2 of the Spatial Filters in Remote Sensing Concept Module. Question 4. How do you define the term convolution? Convolution can be defined as the process where a moving window containing an array of weighted values is used to calculate new pixel values for a new output image. For more information on the concept of convolution, please see slides 4 and 5 in Part 2 of the Spatial Filters in Remote Sensing Concept Module. Question 5. How do high-pass filters and low-pass filters differ in terms of their effects on an image? Low-pass filters suppress the high brightness values in an image. The result of a low-pass filter is the smoothing of the pixel's values. Depending upon the filter size and the actual type of low-pass filter, some blurring of objects in the image can occur. For more information on the concept of low-pass filters, please see slides 5 through 8 in Part 2 of the Spatial Filters in Remote Sensing Concept Module. Slide 9 illustrates the effects of a simple low-pass filter on a Landsat 5 thematic mapper image of the Tulsa regional area. High-pass filters emphasize areas where the brightness values change rapidly across geographic space. These filters are great for enhancing urban structures, sharpening edges or boundaries between land use types, or for making rock joints and faults stand out in an image. For more information on the concept of high-pass filters, please see slides 10 and part 2 of the Spatial Filters and Remote Sensing Concept module. Slide 11 illustrates the effects of a high-pass filter on the same Landsat 5 thematic mapper image of the Tulsa regional area. This concludes part 3 of the Spatial Filters and Remote Sensing Concept module. Additional resources, including this module in the PowerPoint format without narration, can be found on the iGETT Remote Sensing website at http://iGETT.delmar.edu.